remember in your mind, there is another one which speaks about transformer, right? So transformer, you all know about that. Transformer is a static one which transforms electric power from one circuit to another without changing the frequency. So there, the difference is you are not without changing the frequency. Please remember me. You can step up transformer you have and step down transformer you have. Maybe you used in your drives and actuator. I think you have learned. I hope think so. Okay. So some characteristics maybe you have learned about with the help of a transformer on AC circuits or electrical drives and the control. Okay. So, but here we can change the frequency or we can change the switching frequency in order to go for a good amount of application or a good amount of type. Please remember me. So now this may be a simple schematic representation of a step down chopper or buck chopper or one signal step down chopper. So here you have a chopper device, then I have a voltage source, then in the output side I have a resistance. That resistance I may consider here as the output side, where the source is connected to the chopper. Just a minute, students, just a minute. Okay. So my voltage source is connected to one end of my chopper and my gate terminal is connected to my load. And this here indicates the load aspect or the output side. So V naught represents the output voltage which occurs across the chopper or the output voltage which appears across the load. And two important things we should remember about that. When we are able to find out the output voltage, there are two phenomena. One may be due to resistive in nature, either in terms of V equal to IR. With that combination, I can find out my voltage. That is like I naught into R. The flow of current here I am taking is I naught, so I naught into R. Or otherwise, in the power drawn due to this resistive load, I can call it as, because when we speak about a voltage, I should have uh, power drawn from the output side. I can take it as P equal to V square by R. The adequate amount of output voltage which generated on the output side divided by the resistance value also, we can take it as calculation for power in terms of power when we calculate. So two set of calculation, either way, normally power equal to the other one, we may call it as P equal to V into I. In that power, we may have two classification, active power and the reactive power. So now you need not worry about active and the reactive powers. When we speak about all AC components, when the components are reactive in nature, along with the inductive and capacitive terminals are present, then we should worry about my reactive components. That's why in the previous class I told you, when inductive and capacitive parameters are present together, then I may treat that one maybe a storage one or a storing one, or I can able to consider the transient state of my values. So this is what the value is. And so step down chopper with a resistive load, the thyristor in the circuit might be act as a switch, because here these thyristors I told you earlier. Here, what are all the switching devices you use to operate or in order to perform or in order to driving a voltage, that may call it as here as a switch. Okay. When thyristor is on, the supply voltage appears across the load, as we all know about that. When thyristor is in off condition, the voltage across the load will be zero. These are the two important conditions when we speak about step down chopper. So here the previous diagram speaks about the uh, symbol diagrammatic representation of a basic diagram of a step down chopper. So here the step down chopper with a resistive load is connected here, and you have a voltage source, and your thyristor is acting as a switch or a switch, or your SCR may act as a switch. When thyristor is in on condition, definitely we have a supplied voltage across the line. We have a drawing amount of voltage or a driving amount of voltage which appears across the load. When it is in off condition, the same voltage across the load might be zero. Same thing, maybe in the previous chapter we may had many discussions, right? Suppose I need a kind of instant interval with certain time delay or a duty cycle ratio, then I can trigger, or I can give a triggering sequence into a triggering my thyristor or SCR in such a way that with that time delay, I can go ahead with my T on and T off time. Based on that, I can determine my duty cycle ratio T on divided by T on plus T off. Same set of time delays, everything only. I told you, even when we go for any type of wave generation, when we go for sometimes certain devices, you wanted to generate the pulses or generate the sequence of pulses on the other aspect. In one side, you in your system, you may have your input, your supply voltage, everything, and in the other end, certain triggering sequence of pulses, you may have variety of signals. Signals are available. So that is sequence of signal you may generate it by your own with the help of a processor by writing some amount of coding, maybe a microprocessor based on microcontroller or embedded process based, or a latest processor version with the help of a coding or Python or whatever may be. Yeah, kind of pulses may be generated, a triangular wave, square wave, or trapezoidal wave, or impulse wave of signal for a sudden flickering. These are all ways of generating the power you have. Same thing, maybe in the dynamic part of the system on steady state, you might be learned about step signal, parabolic signal, ramp, and the impulse. These are all the standard test signal in order to test your system, whether your system is in a stable condition or an unstable condition or a marginally stable, and also what is the steady state voltage which you are across, or during the transient state, what is the delay, rise, and the peak and peak overshoot across the system. These all things normally we used to calculate with the help of various calculation on your system dynamics. Same thing only there maybe you have used the systematic representation in terms of an order and a type of a system. Whereas here, we are trying to use the components. The components are trying to use here. Even the same components are categorizing towards to, if you write it as a modeling of an equation, then obviously whatever you discussed on the earlier classes in your system dynamics depicts very clearly about that. Inside that. System dynamics, you represented all the systems in a direct manner. But remember, if you find out in the previous diagram, if you find out the voltage or the transient current which are across the load, then obviously we can categorize the system in terms of modeling of a system with the transient steady state and transient state, the steady state equation and the transient state. Well, I hope you will remember there is a type type 0 system with order 1, maybe in the fourth semester you might be learned I equals the same system. If I have right now in the system, I have a chopper or a thyristor, then with the voltage source and the resistance, then what is my output current value? I equal to what? V by R into 1 minus e power minus R by L into T. That is what you discussed on the time domain as analysis of your steady state analysis on the order and system of your dynamics. I hope you learned, right? Same thing. So any type of system, either it may be an electrical or mechanical or hydro pneumatic, that type of system may be converted to a modeling of the system. Please remember me. Any system may be modeled with the help of a suitable differential equation. Suppose now if I wanted to write a modeling of this system, in what way I can use? I can use a Kirchhoff's voltage law and current law. Will you agree or not? You can use Kirchhoff's current law and Kirchhoff's voltage law, and in the name of equation, for example, I into R plus V equal to what? Equal to output of voltage V naught. This may be my equation. Then from that equation, then I should find out what is my current value. So therefore, what I will get? I equal to V by R into 1 minus e power minus R by T. So therefore, please remember Newman, since I am speaking in resistive in nature, so here my steady state value will be approximately 0.69 seconds or 0.7 seconds. Approximately, I may get it on my simulation on the piecewise. Okay, this is another part. Drawing the amount of voltage or the stepping down amount of voltage which appears across the load will have two impacts. One may be the thyristor is on, the voltage maybe appears across the load. That may be quite not that much lesser, but at the same time, when you find out the thyristor is totally in off condition, the voltage across the load, you may be considered it as a zero. The total voltage is assumed to be as zero down. Sometimes if you practically check, a minimal amount of voltage may there so it's little amount of time, that's all. But normally that value will be zero. Okay, now if you see the characteristic curve or the waveform, if you cheat, so the first case, the time versus output voltage, and the second one, time versus your current, output current. So output voltage and output current in terms of what? In terms of time. So here your on time period and off time period mentioned very clearly. So on time period is like your thyristor is in on position, and off time period maybe your thyristor may be triggered to in a off position. That means your on and off together will give you a period of time period, or the, if you wanted to calculate duty cycle, what you will do? T on divided by T on plus the T of time. This is how you can able to calculate your duty cycle ratio. Second one, I told you, I equal to, in general, as per Ohm's law, what? V by R. In that way only, we have calculated the current and the voltage. So output voltage across the load and the output current which across the load may be plotted over. So VDC is nothing but the average value of output or load voltage or DC voltage. ID is nothing but the average value of output or load current. Then T on is nothing but the time interval for the SCR or your thyristor conducting. When your thyristor is in conducting state, or T on time, right? And T off is the time interval for which the SCR is off, as you are aware about that. And T equal to T on the total time, how we will calculate it? On time and off time. T on plus T off time, period of switching or chopping period. That's a period of switching, maybe here it is called it as chopping period. Suppose if you go ahead with the other switches, then the name maybe differs. So here, since we are talking about choppers, either a step down chopper or a step up chopper, we are calling it as a chopping period. Chopping period or chopping time, we may call it as the word. Then therefore, all obviously we all know that f time and the frequency are interrelated. Therefore, f equal to 1 by t, or frequency of chopper switching or chopping frequency. Try to understand the word chopper switching. Please. That's why I told you whenever we start using switches in order to trigger the output drive, then our switching frequency came into existence. That's why people used to speak about all switching frequency, or the variable. Whenever you use any type of switches, but we focus on two things. One is time division and another one is frequency division. That's why switching frequency plays a vital role in order to have good number of applications. Okay, therefore average out simple calculation, average output voltage or VDC equal to what is the total voltage? V. V is the input voltage, that V value into T on divided by T on plus T off. T on divided by T on plus T off is nothing but one state of on conduction and another state of off conduction. Very simple calculation to remember. So T on divided by T on plus T off. So that T on divided by T on plus T off might be considered it as T on divided by capital T. Capital T represents about what? The total on time period and off time period. So all together T on by T will give you about what? Duty cycle, that will be taken as small d. So therefore I am getting the equation VDC equal to the output voltage across the load equal to V into small d. Small d indicates duty cycle, and that represents by T on divided by T, and V is the voltage. So I think it's a simple calculation only, and you can remember. So, and from that equation, when you wanted to calculate for average output current, so when you wanted to calculate for average output current, I equal to what? I equal to basically what, as per Ohm's law, V divided by R. Therefore, VDC, the previous equation divided by the resistance value. What is the previous equation? Previous equation is V into D. Final equation, V, capital V into small d. I think. Okay, therefore IDC equal to V by R into D. R is the resistance across the load, D is the voltage, and D is the duty cycle. And I think the equations which depicts here, don't think that these are all new equations or representations. No, these are all fundamentals you people have Switches you may not aware, but at the same time, these all fundamental equations you might be learnt in your electronic, basic electrical or basic electronic, something you learned in your first year or second year level. So that time you learned about all those things, and these are all the simple calculations might be discussed in even in your solid state switches as well as your electric drives and actuators. Okay, I'm not introducing any equation here new. Some equations are maybe here new, equations may be there. That part maybe after once you come for the physical mode, that time we will drive it in the board also. Maybe here I through this PPT I may take, but the later part once you receive back into college, we may derive it on the board. There's no issue about that. Okay. So these are all simple equations only. IDC equal to V by R into small d. D stands for duty cycle. And RMS value, when we speak about all DC values, root mean square value of the output. RMS is a root mean square value of the output voltage. Therefore, square root of the entire term, 1 by T into integration of T 0 to T on V naught square into, that is I square R into dt, or V naught square. V naught square is nothing but I into R. Okay. But during T on time, what is the value output voltage V? Because we assumed that during the T on time only we have a voltage, but during the off time we don't have the voltage. That is what the basic operation of a chopper we have discussed. Therefore, the RMS the output voltage equal to 1 by T integration of 0 to T on V square into dt. If you take the integration out, then what will happen? V square by T into T on, so that V you can take it outside. Inside the square root you have a V square, so you can take it out. So V into root of T on by T. So that is called it as V into root of D. Why we are at the end of the equation we have written V into root of D. Root of D indicates what? Duty cycle. The root of T on by T indicates what? Duty cycle. Therefore, the output voltage V naught equal to square root of D into capital V. V is the voltage and D is the duty cycle. T on divided by T on plus T off. T on plus T off represents capital T. And the same thing when we calculate for output power. I told you P equal to V into I, or P naught equal to V naught into I naught output power. Therefore, I naught equal to what's the value? V naught divided by R as per Ohm's law. Therefore, output power P equal to, I told you this equation, right? Power dissipation through the load. Before starting this calculation, two equations I told you. One is P equal to V into I. Another one I told you, P equal to I square R, and dissipation takes more than one. Then in terms of voltage, I told you P naught equal to V square by R. So these are all the three relation. At least please remember in your mind. Okay. One is the generic power output P equal to VI. Next one, V equal to, when you speak about in terms of current, I square R. When you speak about in terms of voltage, V equal to V square by R. Have you got my point? The suffix term, don't confuse that. The suffix term always depicts about the based on the output terminal or the input terminal, but meaning should not change. My meaning should not change. Try to understand. Either if you apply Kirchhoff's law or Kirchhoff's voltage law, or even in your what I say Ohm's law, equation structure may change or the notation might be changed, but the meaning should not change. Therefore, finally we can write it as P naught equal to D V square by. Just a minute. I have received a call. Just a minute. Yeah. Therefore, P naught equal to D V square by. And one more equation, effective input resistance of a chopper, or Ri equal to V divided by R equal to I equal to V by R, or V equal to IR, Ri equal to what? V divided by IB. So otherwise we can write it as Ri equal to R divided by small d. Small d may be written by in terms of duty cycle. So the output voltage can be varied by varying the duty cycle. That's what I told you. We can give intervals according to the duty cycle value which we are considering. Based on that, what will happen? The amount of sequence of my pulses or my waveform will have a shift based on the time delay and other things, or maybe based on my on time and off time. You got my point. So this is how we can have an adjustment on my switches. That is why this type of wave generation or pulse generation plays a vital role on the application point of view. Many devices with more system, you may have variety of input signals on the various other systems. We may call it as in general system, but many, if you take it on the whole circuit board, uh, you need not stick on to a single voltage. Sometimes every individual small system, I may have a variety of voltage. One system I may give 12 volt, and another one I may give 9 volt, another one I may give 6 volt or 5 volt. So it depends on my configuration and my board which is available for my system. So like that only here I'm speaking about the triggering of pulses, or the sequence of pulses may be varied according to the time delay and according to the frequency which is required and according to the speed of the drives. When I wanted to drive my motor or generator without any delay, then I can go ahead in one direction. In another direction, if I need certain time delay, for example, at one instant, my device have to run it in 1000 RPM. Then I need little time delay. Then again, I will have a fall in drop on my speed. Then I need maybe 500 RPM or something. Again, I'll have an increasing. Like that, certain there are variable speed drives people have. So certain speed drives, you may have a constant speed. There are n number of applications are available. Certain speed drives may require constant speed, right? For example, 1000 RPM or 1500 RPM or 2000 RPM, whatever may be. Okay, that case is different. So certain device I may have a initially I may have a high speed, then later part I may have a falling state. Like for example, initially I may have 1000 RPM, then later part I may have a 800 or 500 RPM. So like that, I can able to adjust my speed always with the help of a triggering or sequence of triggering the pulses. Thereby we can adjust the speed of a particular pulse. So like that, lot of triggering methods are available. Di by dt or dv by dt. These are all one in one aspect. We can speak about the protection of the switches. At the same time, these are all on the other side. We can speak it as these are all the various commutation methods. On the first unit in the end part one topic, we discussed about some a kind of pulses we discussed on the with the help of a transformer. Finally, when we closed about the commutation in one PPT, you may have a input, and in the input side your primary is connected, and in output side your load is connected. From the output you had a current. That current is opposite to the thyristor current. Thereby it is suppressed, and the voltage value is minimum to the holding level. This is how we that may be the external. That means that is called it as the external amount of commutation. That's what I told you. So we can have internal commutations as well as we can have the external commutations. By varying on this, the output total may be varied by the duty cycle. So I don't think you will have difficulties on the equation. Initially, we find out the output DC voltage with the help of duty cycle, and three important things. Please remember in your mind. One, most of the equations based on I equal to V by R relation. Second one, P equal to VI, or P equal to I square R, or sorry, P equal to VI, then P equal to I square R, and P equal to V square by R. Then duty cycle equal to T on divided by T on plus TF. Duty cycle altogether cumulatively we will consider it as small d, and otherwise we can call small d equal to T on by T. Capital, and the T indicates T on plus TF. Certain books, if you refer, the total time might be taken as capital T. Don't confuse that if you refer to some textbook. Okay. Then we calculate the average voltage. RMS value always will have a square root value. Then output power P equal to V into I, or output power P equal to V square by. Next one is the methods of control. What are all the methods of control we have? Various methods of controls are available in order when we go for driving the speed of the particular drives, or a motor, or a turbine, or a generator in terms of a hydro, or the thermal, or a pneumatic, or valves and other areas. There are a number of applications are available. So here, please remember in your mind, the methods of control speaks about the output. One is maybe a pulse width modulation control, or a constant frequency operation, and another one variable frequency. That means what we are trying to focus much on that frequency. I told you long back, right? I kept on insisting on about the frequency range. Even many of your own robotic final module hardware drives, you speak about that in one side, with the help of a control of a motor or a modeling of a motor, you should also know how to control the, or by changing the frequency, or with the help of a suitable chopper, we can able to go ahead with the variable frequency and other things. The output of DC voltage can be varied by the following two methods: pulse width modulation, PWM. We may call it as P capital P, capital W, and a capital M, pulse width modulation. There is some more techniques are there. People may call it as sinusoidal pulse width, asymmetrical pulse width, then pulse width cosine type. These are all the various other pulse width modulations also available. Normally, PWM, then asymmetrical PWM, PWM just inverse, asymmetrical PWM, then sinusoidal pulse width modulation, SWPM, sinusoidal pulse width modulation. These are all the various modulation techniques. But we remember, if you look into the entire circuit aspect of these type of power electronics devices, always was most of your circuit connections remain same. Please remember, being a mechatronics, you are not going to design this type of circuits. Some people belonging to electrical will drive all those things. They will give it to you. You have to decide according to your application. Then you have to decide about that, whether what sort of delay is required, what sort of delay angles are required, or what sort of pulses are you going to give according to your output. Please remember, always when we speak about in terms of application, there are n number of modules may be associated, n number of toolkits may be associated, n number of other areas may be associated. We may focus on a particular area only, provided remaining other areas might be available, may be readily available. That's what I told you. If you go for any speed drive, or if you consider for any application, but in the other side, if you check the hardware aspect on the drives, power electronics drives, or the industrial drives, if you check, most of our circuit diagram looks like similar. Sometimes a number of switches may be increased. Number of switches in the sense I'm speaking about UJT, MOSFET, thyristor, triac, and diode, all those things. Suppose if you may ask, I told you a long back, if we increase more amount of switches, we'll have lot of losses. Switching losses are more. When I have switching losses, then ultimately I should lose my frequency. Please remember, my switching frequency may differ. That's why periodically I won't get the continuous output, or I may not get the required output. That is the challenge we have. That's the other part. But if you may ask a question, even robotic specialization, you are going to devise, or you are going to give a proper coding, or you are going to give a modeling and a hardware structure of your robotics, or robotics with some other manipulators and other things, or there are a number of variety of robotics are available in the market now. Many people are looking into more amount of research on that area, more amount of robotics into existence for various domain of application, even medical robots. Many things are there with many workload may be different. Operations may remain same, but the functionality, even military purpose, the structure may differ, or the usage may be different. Military purpose, or for secrecy data transmission, or secrecy movement from one place to another. All those things okay. Or in fire area, how your robot will react. These all things, a certain amount of characterization may be differ. At the same time, if you look into the other aspect on the electrical connection on a drive you part, most of your connections remain same. Only switches may differ, or your number of components may either increase or decrease. It depends on the output value, or depends on the output voltage which is required from you to trigger or drive the particular module. Please remember. That's why various number of pulse width techniques are available, because pulses are much cheaper. I think maybe you may have done some laboratory also. I think even in microcontroller, some square wave generation, triangular wave generation, or I don't know what some more maybe. I don't know what other things I know you have done. Maybe you are done with the help of microcontroller based instruction based coding, right? You are all learning instructions, ARM instructions, and other things. So with the help of that microcontroller instructions, you may be controlled. Okay, you are maybe you are trying to generate the amount of it. That width and the time period, everything will be changed according to the values which we are trying to set. So here, because based on that width, based on that time period, based on the duty cycle only, the total function of the driving part will differ. We are simply learning, okay, I am generating this pulse, or I am generating triangular, trapezoidal, or I am generating square wave pulses or rectangular pulses. We are simply telling. Generation of pulses very simple. Even if you take your CRO and if you can take the probe, I think you all know about CRO, right? Cathode ray oscilloscope, the laboratories, and you generate the pulses with even certain amount of jump pulses by your own. You can generate with the help of a suitable CRO. You can generate, and that pulses you can give it to the particular device. So here, what are all the pulses we are trying to speak everything to give a huge amount of little amount of delay which is required for a speed drives in order to go for a smooth operation. Pulse width modulation control or a constant frequency of operation. So here this modulation control, or we may otherwise we may call it as a constant frequency operation. And the second control we may be taking it as a variable frequency control, or the drives might be call it as a variable frequency drive. So this type of drives will be called it as a variable frequency. Okay. Pulse width modulation, your T on is varied, keeping the chopping frequency and the chopping period T constant. That means your T on time, your on time is varied, keeping the chopping frequency F and chopping period T is constant. That means your frequency and the time are kept to be constant by varying your on time. Output voltage is varied by varying the on time T. That means your output voltage, or on the output side on the resistor side. In the previous diagram, we just saw about the output side. We had a resistor. Sometimes we may have resistor and the inductor combination, otherwise RLC combination, or you replace all the load and you fix the application load, whichever load is required, or whichever application, whatever application you are trying to call in order to connect or integrate or giving a link to the electrical power drives along with the application, that will be called it as an industrial drive or electrical drive. That drive here, that output voltage may be varied by varying the on time or T on time. Okay, this may be another waveform representation. One may be output voltage. Both the diagrams, if you see that, you yourself can able to see that. So the width, the amplitude, time period, based on the amplitude and the time period. I think both the diagrams mostly amplitude maybe remains same. At the same time, which is getting differ, your time delay. On time may be less in one case, off time may be more in the first case. Second case, on time may be in more, and off time may be in. Depends on that what will vary. The total operation of the time and total duty cycle may differ. So this is how the variation you can give. Thereby you can control the speed drives or a variable frequency time. When this changes comes, automatically your frequency and the time may differ. What my point or not? So with that only we are trying to drive the. So I hope from this diagram I think you can able to understand this difference. And the variable frequency control. So just a minute, I have a cup of water. Okay, sorry. Please be online. Just a minute, I have a cup of water. Okay, fine. Now, the next one might be taking it as a variable frequency control. Frequency control. Okay. So here, chopping frequency is varied by keeping either T on and T off are constant. Then, to obtain the full output voltage range, frequency has to be varied over a wide range. This method maybe produces harmonics in the output for a large amount of TF. That means when my device is in more off time state, or more off time, or more time my device may be off, and a less amount of time my device may be on, will give an additional impact on my harmonics on the output side. By may become discontinuous. That means There are two things normally we used to speak about continuous signal. I think in the last time you have learned about signal conditioning and sensors something, right? So that time you might be learned about continuous signal, discontinuous signal. How do you sense the signal with the help of a sensor or all those things? Okay, that was all the other part. Okay, but you know very well about that. Your signal may have certain amount of signals may have quite weak in nature. Certain amount of signals might be very strong in nature. How do you amplify with the help of an amplifier or with the help of or so how do you generate signal with the help of an oscillator? These all things okay. You all got fundamentals. Okay. When signals are much weaker, we wanted to have a power amplifier. Thereby I can able to amplify. So today's scenario, please remember in your mind, we are very easily here we speak about all the drives and either it may be a AC drives or a DC drives. So here we are trying to speak about all harmonics. Normally in AC drives we speak about harmonics, and in DC drives we may speak about mostly about distortions. I think in the electronics lab, when you see some waveforms on the CRO, cathode ray oscilloscope or something, a quite amount of waveform might be flickering for some amount kind of time. Then again it will be vanish or disappear. Again it will come. Something like that. I think you might be noticed. Okay, a kind of flickering, a kind of distortion. I think you may call it as in the other way we may call it as a damping and various type of damping may be analyzed in that earlier semesters, like what I say, over damped, under damped, critically damped, undamped, all those things. Okay, you learned about in terms of when you speak about the dynamic aspect of the system. Okay, now I'm not going into that area. Okay, therefore, these methods may be produced normally in AC circuits. Please remember in your mind, the off-time periods are much more than and on-time period is much less. You will have a continuous signal, but with the discontinuity. We have a signal, but at the same time, I may have a quite amount of kind of discontinuity. That time, my harmonics are unwanted things are maybe incorporated along with my originality or in my current or voltage. Thereby, it may be treated here as a discontinuous. When it may be a discontinuous one, then I may not be able to get the required amount of light. This is how one or the things will happen. Even the same thing for in terms of your DC analysis, maybe I think even the signal conditioning and signal analysis may be noticed. Even our own mobile phones in terms of signals, if the provider network is not giving a proper signal to the relevant areas, then you may call it as sometimes you may tell that, sir, uh, your voice is not audible or we are not able to hear your voice. Maybe with the help of a data and the signal only, with that only through that my analog signal may be converted as a digital one. Again, it may be converted as an analog and you can able to hear it in your headphone or whatever maybe you have. Quietly speaking, my voice signal may be an analog one, right? My voice signal may be a, or my speech signal, I can call it as. I can call it as my speech signal. This one may be an analog in nature. This analog signal will be converted as a digital one through the processor. Then again, with the help of my earphone or whichever I'm speaking, with that processor, it will be converted. On the other end, you are hearing from various thousands and thousands of miles far away from your country, or from, sorry, nearby India, or some of you may be in abroad, or whatever may be, wherever you located. uh, you can able to hear my voice or instantaneous of operation or an instant operation. A conversion of kind of conversion takes place immediately on A to D and D to A conversion, analog digital and digital to analog conversion on my speech signal. But will my speech signal sometimes may have an adequate amount of lesser amplitude or lesser time delay? That everything will be amplified properly and you can able to hear my voice. Provided the same signal will be carried over by the other signal. That signal will have a weaker instance. What will happen? Sometimes you may not be able to hear due to poor connectivity or my speech signal. Sometimes you may not be able to retrieve my speech signal as an analog one in nature due to the poor discontinuity of my signal, data signal, which is available or in the name of internet or whatever may be, or during thunder, lightning, or uh, maybe some climatical changes or some disaster time. All those things sometimes we may able to fear our continuous running rainy seasons. These are the times we used to find little difficult. to hear the frequency, to maintain the frequency, as well as to retrieve the signals or to retrieve those audio or speech signals. So same thing. So please remember in your mind, the unwanted kind of things may be presented here that may be called as harmonics in the output, or the due to the large amount of T of load current may become the discontinuous mode. So that's why this signals might be becomes a discontinuous mode. So, okay. Now this diagram, both the diagrams speaks about the output voltage. I think very simple to depict. In, on time, in first case, on time and off time are almost equal. On time will have a same interval, with off time with the same interval. And second one, on time will have more interval than off time. Again, on time will have more. So like that, you can have adjustment. But at the same time, if the off time periods are more and the on time is less, then what will happen? You discussed about the earlier case. They have a kind of discontinuity. And that's why variable frequency, right? We have discussed about that one. A kind of discontinuity or a discontinuous signal might be happened. Now the next one, step down chopper, second category. So far we discussed about the first category. Okay, now we are going to discuss about the second set of. Okay. Now from the previous diagram, I think everyone noticed about the diagram. Earlier diagram, I have a voltage source, I have a chopper or a thyristor based one. Then output side, what I had, I have a single resistor. I have a resistive load in nature, and output I found out across my load. That's what the diagram, right? Very simple diagram. I have a voltage source. The center part I have a chopper or thyristor based chopper. Then in the output side I had a resistor. That is what my first chopper we discussed. Very simple representation of a circuit diagram. The same circuit diagram, I think you can draw it in a PSpice software and you can check the output. You'll get an output on the PSpice screen, or even in MATLAB, I think you can check with the power electronics toolkits. I think SRM many students have MATLAB license by your own, right? I think colleges provide some MATLAB license or something to you people on the perpetual mode or something. We do not know, but maybe in that case, if you have a toolbox in your system, you try for that. Okay, you have a separate toolbox called. There are various number of toolboxes are available. One maybe call it just power electronics. That one, if you go, you will get all these components. Then you just place it, and in the output side, you connect your scope and find out the output voltage on the screen, and you can change the value of your resistor or inductor or even the diode. And here, when we speak about the stop down chopper with the two loads, what are the loads? I have R, L, and L. Here, I have a load RLE. So that means resistive and inductive loads with a minimal amount of source I have. Okay, that entire area will be considered here as the output of my chopper. So my input voltage is V and my output voltage is V0 and my output current is I0. From my point, that is the only difference you have in the previous diagram. Okay, but here in between, because when I have either a inductive component or a capacitive component, what will happen? I may have a charging time. At the same time, what will happen? At some instant, what will happen? I will have a discharging time, right? Yes or no? Will you agree or not? So at one instant, or a kind of instant, I may have a charging time. Then I will have a discharging time also. That's why, in order to prevent that one from with the help of a freewheeling diode, FWD indicates what? A freewheeling diode is connected between the source and the output side. So between the source and the output or across the voltage source, I had a freewheeling diode. FWD indicates what? Freewheeling diode. And one more thing, whenever we used to speak about L and C, I told you on the previous class also, a kind of a storing, a kind of a storage. I told you that is the speaking more beauty on electrostatics. Now, with that principles only, many battery designs are shooting up in the society. How much time is required for on, then how much charging, then how much time required for the discharge. Even when you have, for example, if you have a drone, so your L and C value along with the battery, it will decide about, even though your motor specifications may differ, At some height, for example, 10 feet, it is flying and it is trying to spread some seed or something, or maybe it is running for some time, wanted to run for 10 minutes or 15 minutes. But everything based on the battery level only. Depends on the battery amount of storage, you will have a charging. Okay, while it is in running mode, you will have a discharging. Depending on the discharging amount of quantity or phenomena only, it will take the amount of time or the run time on the it can fly. So this is what the storing. So storages everywhere takes a vital role, even not only for the simple circuits, even for any storage requirements or battery storage we speaks about, or NNC component. So here also you have a L will have a charging ability to trigger, because once the current is flow through the L, what will happen? It will be energized, right? It's a coil. Same principle only. I told you long back. Even in your houses, lot of heaters are available. Yes or no? If you see the heater in the bathroom, if you see in your house, it may looks like a big shape, a big drum, something like that. Will have some inlet wall, outlet wall, some red indicator, and other things. If you just suppose if you feel that okay, you don't have to get an adequate amount of heat, then make it off, switch off the device, then just remove the top layer of the heater. If you check inside, you have a coil. You will have a coil along with the resistive elements. That's what the internal structure like. Maybe sometimes at time delay unit may be connected. An operational op amp with a time delay unit, because some times it may be hot, then some quantum of time it may be with a slight cold. Then again you will have a hot, something like that. Now you can set light. So, but all these things, please remember, the heater and all, it's a coil only. I think you may have heaters, you may have induction stove. I think you all have, right? Induction stoves, then microwave oven, baking items. So all things, please remember, based on the inductive phenomena or Faraday's law on electromagnetic induction effect or the magnetostatic effect. Please remember me, don't forget it. So here, inductor will have an ability to discharge. At one instant, again, you need to have a discharging time. So in order to avoid the reverse amount of current which flows through that, so a freewheeling diode may be connected here to protect your chopper from the reverse amount of current. Then thereby you can be able to get your output voltage or a step down output voltage which appears across the RL load or which appears across the output side. So here RL, L and E are connected across the output side of the acting as the load here. RL, E together acting as a load. That load may be considered here as the output voltage V0. When chopper is on, the supplies may be connected across the load. You all know current flows from the supply to load. We all know that. And when chopper is off, current continues to flow in the same direction through freewheeling diode due to the energy stored in inductor. I told you all those things, right? So the same thing. Again, the load current can be continuous or discontinuous depending upon the value and the duty cycle. So the load current or the output current may be continuous or discontinuous depending on the value of your L and your duty cycle. Please remember in your mind. And one more thing is there, please don't confuse that, okay? You refer some quotes. Now, the first line, the load current can be continuous or discontinuous. Then, in that case, how do we write the equation? We can write an beautiful equation. IL equal to what? Integration of 1 by L into 1 by L dt. That is, please remember even that dt, that is different. Okay, here your duty cycle will not associate. So the amount of just a minute, and the amount of we find out the load current I equal to integration of 1 by L into dt. So please remember in your mind that why inductance will speak about the integration property over here. Capacitance will speak about the differentiation here. That's why when we have electronic circuits, we may introduce operation amplifier. I think operation amplifier you may be learned, right? Op amp. I think you people have heard about that being in sixth semester. OPAMP, op amp. Yeah, there are basic physical properties you may be learned about adder or subtractor, then integrator and differentiator. Yes or no? I think you may be learned. So here, discontinuous amount of continuous or discontinuous amount of load current depends on the value of your L as well as your duty cycle. Duty cycle depends on the off time and the off time. And second one, for a continuous current operation, load current may be varies between two limits. For a continuous amount of current operation, definitely load current may varies between two limits. What are the two limits? One may be the maximum current and another one may be the minimum current. It depends on the discharging amount of time or depends upon the duty cycle ratio. And current becomes equal to I max. The chopper is in. That means I max and I min or sorry, the I equal to I max. When the current becomes the maximum current, then obviously a chopper will be in turned off condition, and it is turned on when current reduces to minimum condition. So now next point is when current equals to I max, the chopper is in turned off condition. Again, from turn off to turn on condition, what will happen? Already current is in equal to what position? Maximum position. Then that maximum position will have to be come down or reduction or a kind of reduction takes place when the current reduces to I. Sorry. So that the current will be have a reduction amount of value, or the current may be reduced to I min or I minimum, current minimum. Okay. So this may be the characteristic waveforms. For the first one, we will have T on and T off, and second case we discussed about the two things, right? I minimum and I maximum. The continuous current and discontinuous current. Second waveform that is very clearly about the continuous amount of current. When discontinuous amount of current is there, what will happen? Due to the more amount of off-time period. So where the interval takes place or the discontinuity. So please remember in your mind, your output current will have a discontinuous image. So output voltage and the output current on continuous mode and the discontinuous mode we have got. Continuous mode and discontinuous mode might be obtained in the previous case. Like for a continuous operation, your two of the conditions, I max and the I minimum. Current equal to I max, then chopper is turned off. And when it is to be trying to be turned on, then the I max is reduced to I minimum. Got my point? So with that, this is how the waveform. Output voltage of the waveform or the with the on time and off time period or the total time T period. Then the second third waveform, which depicts very clearly about the I minimum position and I maximum position. Again, it will come back to the minimum and the maximum. So from this, the third one speaks about the discontinuous amount of current on the output aspect. So far, we discussed about the step down chopper. So step down chopper, we have discussed about that. That means step down chopper, we are trying to reduce the amount of voltage. And the step up chopper, obviously, we are trying to boost up. The earlier case might be considered here as the buck or stepping down of the operation, and here may be boost in nature or buck boost, boost operation. Buck may be in case of a reduction. Please remember. And the principle of step up chopper. So here again a chopper diagram. So here I have a voltage source, then I have a inductor, then I have a chopper. Again along with the same diagram and the capacitor, and finally I have a load. Okay, comparing to the previous one, what is the speciality here you have? Earlier one we discussed about that as a step down chopper. Step down chopper, you all remember the name. See, one important thing, you need not boycott any theory or this diagrams. All by your understanding you can write. Okay, this paper is not a difficult paper or anything. This paper is also a generic paper, and more or less this paper is one of the easiest paper for you people. The reason I told you earlier, being at the one reason being a third year, you people have learned drives and solid states on a continuous manner on a same semester. So now both the things are combined and you are learning. Maybe the here is still we are speaking about load only. Maybe in the later part when it comes in the other units, we may have a drive, we may have a motor or the other turbine or the elevator, lift lamp. All those things may be connected across the load or some application. But don't confuse that with the I think driving part. Some kind of application may be connected. So for you people, as far as my understanding is concerned, This paper is very very easy for you people to write being a third year. Diagram and all you need not boycott simply by spending more amount of time. You need less amount of time to just have a glance and by understanding certain basic physical activities which happens on the society on the application. These are all towards on the industrial perspectives. Maybe in the final year, the same set of version on the other way, we will have a class, maybe call it as industrial electronics. The next is seventh semester, we will have another subject called industrial electronics. That time, all these things are focused towards the industry on the current trend, how it is happening on the various terminologies or various working type models. All those things only we are going to deal it. See, in theoretical way we may learn something, but practically when you go for that certain amount of drawbacks, certain amount of losses and other things we may find out, right? But whereas when you go to industry, the style of functioning may be different because we may have all upgraded scale version, right? But whereas in colleges or schools, we may learn all the scale down versions we may be used for the to know about the system, to know about the adequate amount of fundamental, to know about little knowledge on the particular aspect, thereby to put our skill or to explore our ideas into action. That is the normal way of learning. So please just have a comparison so that you can be able to remember all those things. Okay. So here a principle of step up job work comparing to the previous diagram, we have one additional component C is present here. That means I will ask a question. Earlier case we had a charging. While discharging through freewheeling diode, okay, we were trying to reduce the amount of current which passes through the chopper or a thyristor, and we just step down the operation. But here two components are connected. I chose storing components L and C are connected. That means more amount of charging and discharging. Sometimes discharging will happen once the discharging comes to an end. Again, what will happen? Charging will come. Have you got my point? So, what kind of operation of flow here? Charging, discharging, again immediately charging and discharging. My point. So please remember in your mind. Suppose, for example, when a coil is energized, then the power is off immediately to be discharged. But now, inductor and capacitor together charge. So my inductive charge is maybe in a discontinuous mode. My output value becomes zero at some instant. But whereas my capacitor will have an ability to give an amount of discharge. That amount of discharging current will have an ability to give a kind of charging to my inductor on a closed loop manner. Please understand. So thereby here I have a continuous amount of operation on the charging and discharging. You got my point. So here the two storage elements are getting over here. And I told you when we started the class, I told you uh, always when we go for analysis or when we go for characterization, we also should have to a little kind of mathematical knowledge to model any system. Always we speak many things, but at the same time, when we have more ideas, I should implement my ideas by writing a kind of expressions with the help of my differential equation or some integral equation. When I start writing with the differential equation or integral equation, all those things in terms of what time domain. And I wanted to convert to frequency domain, I should go ahead with the again maximum fundamental, right? Laplace transform. Or if I go with the again with the time domain analysis or the various characterization, then I can go ahead with the Fourier analysis. I think in mathematical we may be learned about Laplace analysis, Laplace transform, similarly Fourier transform. The Laplace transform, you may have a frequency domain or S domain. We may call it as S domain. I think these all things you might be learned in deeper way on your system dynamics, I'm sure. Yes or no? Very sure. So this is how all mathematical relations came into existence into the picture. Thereby, we can model the system. Once you have a modeling, we can able to frame a state model of the system. I think in the system dynamics, you might have done this same system. You might be done it in a systematical block representation. a kind of a block diagrammatic representation. You may call it as each block may be G1 and H1, G may be a open loop and H may be a closed loop. Leave it. What kind of exact system will be? System may be, right now we are dealing with the electrical system, and maybe the other subject in the previous hour you may be learned about some electronic system, or you may be learned about some hydraulic system. All systems, principles and philosophy will come into picture on that. Please don't know. So that's why whenever you learn for any system, try to improve your skill by writing a kind of mathematical equation, thereby in order to go for the other analysis. That will give you a clear understanding on the coding technique when you go for to introduce some code, a kind of coding for a process. Otherwise, in a overnight or in a single at night, we cannot bring any miracle for writing a code. A kind of little knowledge is required with the help of basic mathematical fundamental, not other than that. Please remember me. That's why parallelly in engineering, you people are learning adequate amount of mathematics to know about the analysis part of the engineering problems or engineering problem statement. Got my point? So here, if you wanted to write in terms of Kirchhoff's voltage and write the equation, what will you write? L into di by dt. L into di by dt. And capacitor, how you will write? C into dvc by dt. L into di by dt in terms of what? Always the inductor speaks about the current. Inductor's current through the inductor. Please remember. And capacitance, how you will write? The voltage across the capacitance. The voltage across the capacitance, or C into dvc by dt, or the differential operation. The other one I told you, 1 by L integration of what? I dt. That means integration property. Inductor speaks about the integration, and the capacitor speaks about the differential value of that differential and integral equation. You can convert it to what a transform, Laplace transform. Maybe for initially we will write the equation in terms of time domain, then convert to what equation? Laplace transform. Once it is converted as Laplace transform, what you are getting exactly? You are getting a frequency response. That's what I'm trying to speak here. That's why I told you time response and frequency response are interrelated, and these are all the much important tools to play for many operations. When you go for variable drive or when you go for a constant drive, irrespective of any speed drives, when you go for any type of transformations or any type of conversions. Got my point? So here you have output which is kind of load. Here the load is just mentioned as load. Okay. Earlier one what they mentioned R, L and the E combination. So here even see you may ask a question, sir. When we write on a generic way, for example, a step down chopper, instead of R, L, E, shall I put it as load? Yes, you can. Yes, you can. That's what I told you. The objective remains same. My outcome will be depends on my usage or depends on the need on my output area. So normally, please remember in your mind, output side, you can very well use the word as called what? Load. You need, instead of putting R, L and E, you can blindly you can write it as a load. So people will have an understanding that that's what the meaning here. Always load will speak about the driving part or the output part. So continuous amount of charging and discontinuous and charging and discharging may take place on a continuous manner. Thereby you will have a sequence of amount of pulses generation. Thereby you can able to maintain your frequency and the output voltage also maintained. So one, we can able to obtain the output current through an inductor, and another one output voltage across the capacitor also we can able to find. These are the two values we can easily find out with the help of the step-up chopper. Thereby you can able to boost up your voltage for the adequate amount of level, or sometimes you can able to maintain the constant amount of level of voltage. Okay. Now the step-up chopper is used to obtain a load voltage higher than the input voltage. And what is load voltage? Output voltage. It may be the higher than the input voltage. That is what the meaning of step up, right? Okay. The values of L and C are chosen depending on the requirement of the output voltage and current. Please remember in your mind, the value of the L and the C, inductance and capacitance are chosen in such a way that depends on the requirement, depends on the need, depends on the driving rating. Every output you will have rating, right? Yes or no? Every output you will have rating. According to the rating only, you will decide either the on time or the off time or the running time or the movement time or the transportation time and or the required amount of transient time to stabilize themselves, or in order to go ahead with the drastic line of flow on the to reach about the settling time with a little amount of shoot values. So please remember, value of L and C are chosen depending on the requirement of output voltage and current level. When the chopper is on, the inductor L is connected across the supply. When chopper or whereas a thyristor is on, the inductor L is connected across the supply. Because inductor L is, you all know about it in the previous diagram, inductor L is connected across the supply, nearby the supply only. The inductor current rises. Current automatically what will happen? Inductor will have an ability to trigger or a kind of excitation may be happen. That's what I told you. That is the basic principle on your heater. And coil gets energized, what will happen? It may be dipped into the water, amount of water. Water gets heated up. When the water heating maybe if it goes beyond the level, then we will have a time delay or a timer with the help of a suitable timer. Then we can reduce the speed automatically, reduce the heat automatically, or reduce the temperature automatically. Because earlier, maybe during your school days, there was no system like that. You don't have a time circuit. Once you feel that when the water gets heated up, immediately we have to switch off. Otherwise, after some extent, it will burst, or then there are a lot of hazardous things that happened on the heater when they installed some 10, 15 years back in the houses or residents. But now, okay, there's no much hazardous in nature. Every people are aware to how to use, and every people are how the water heating systems are now automated everywhere. Now people are speaking about all automation, right? Automation systems. Even you people are also learning this time semester as the intelligent and automation system. That means you are trying to give all automation principle with the help of certain intelligent controllers, with the help of a suitable intelligent device. Thereby, you are trying to control the entire set of operations. And the values of LC chosen depend on the requirement of the output voltage. Then when the chopper is on, inductor is connected across the supply, then the inductor current rises, and obviously, and the inductor current stores energy during the on time of the chopper. That the things I hope you all understood. So during the power supply is on, obviously your inductor gets charged. When the chopper is in off condition, what will happen? So the inductor current will flow through the diode and the load for a period. So initially, at some instant of time, your chopper is in on. So inductor gets charged. And when the chopper is in off state, that time what will happen? The amount of charging will have an ability to have a discharging on the inductor. That amount of discharging current will have a flow to the diode and the output of, during the for a period of T off. T off means what? Chopper is in off condition. Got my point? Okay. Next, again the current tends to decrease, resulting in reversing the polarity of induced EMF layer. Due to this one, we are trying to speak about the induced principle or law of electromagnetic induced principle. Says about what? E equal to minus d pi by dt. I could think you all remember from school days onwards, you are all learning, right? The rate of amount of the rate of decrease of flux, the amount of energy which is excited through is directly proportional to rate of decrease of flux or the rate of decrease of the current of energy. E equal to what? Minus d pi by dt. That's what your Faraday's EMF says, or electromagnetic induction says, or EMF expression says. Then the current tends to decrease, resulting in the reverse polarity of the induced EMF in L. Therefore, the voltage across the load may be written as now only which component we consider? Only the inductive component only we consider. Okay. Next one is, therefore, when you write the equation, output voltage equal to what is the original voltage? Capital V. What is the component which is present? Inductor. I told you you will write the inductance in terms of what? Current. Do you remember or not? L into di by dt. So V not equal to V plus L into di by dt. This is what I told you about all mathematical modeling of the equation. I think in the system dynamics, the end of the part, you might be discussed about state model of a system, the output equation and the state equation and output equation together. You call it as a state model of the system. I think you people have learned. With the help of a state model, you are trying to introduce the kind of requirement of poles and zeros on the system. Thereby, you can have bring changes on the frequency response analysis. Okay, that in the other case, you leave it. There, you may be learned about state modeling of the equation. When you write for state modeling of any system, I am speaking about all those things here on the electrical aspect. So, for example, I am saying that I think you all learned just one semester back only system dynamics. Suppose if I have a system for an electrical system, I have two inductance and one capacitance. Then what sort of matrix will I be getting to write the modeling of my system? I will go 3 by 3 matrix. So please remember in your mind, depends on the energy storage elements which are present in the things. Based on that, I will assume the state variable. Once I assume the state variable, then I can go ahead with the, for example, x1 dot, x2 dot, x3 dot. What's the state equation? X dot equal to ax plus bu, and y dot equal to what? Cx plus du. Yes or no? These all things I think you have learned. That is what so far I told you. If you can able to make yourself to write a kind of modeling the expression, then you can convert that one to a state variable analysis. With that state variable analysis, with the help of Laplace or Fourier, then you can categorize the expressions and you can go into the deeper analysis and various case studies by cases. When inductor is present, what will happen? When inductor is not present, what will happen? When the amount of the voltage is reduced, what will happen? Or during the on time, what will happen? Or during the off time is more, what will happen? These are all detailed analysis we can do, and we can go ahead with the analysis on frequency. So when the operation of the inductor current is forced to flow through the diode and load PLT off, therefore the current tends to decrease in the reverse polarity. Voltage across the load will be written as V naught equal to V plus L into di by dt. From this equation, we know very well about that. What inference you are trying to take from this equation? What inference are you trying to take? Definitely, we know that my output voltage is greater than my input voltage. That's what I told you, right? That is the main operation on my boost operation. So therefore, my output voltage V naught is greater than my original voltage or my input voltage. Step up chopper continuation, that a large capacitor C connected across the load. So far we discussed only with the L, right? So far we spoke about only with the L. Now we speak about with the C. Step up chopper, a large capacitor is connected across the load, will provide a continuous output voltage. Large amount of capacitor C is connected across the load, will provide a continuous output voltage. So diode always prevents about the current flow from the capacitor to the source. Otherwise, what will happen if you don't connect your diode? What will happen? Sometimes your switch may be damaged. There are various short circuit we used to identify, right? Due to the fluctuations on the voltage. On the day I told you about your washing machine or something, I told you normally where the mistakes will happen in the process of code. Or the other part, the mechanical part, and then we don't get any mistake. Even sometimes the mistake may be rarely happened with the sensor which is available in your machine. And that is rare case due to some rust or the other things, some water leakage, some other things. That time maybe sensors may not be worked or and might not be able to sense the adequate amount of property or sensing the characteristic. That time only that issues may be. Otherwise, normally all these things will be based on the reverse amount of current flow through the particular device, and the device may be like, because these are all very sensitive in nature. These all electric components. Even you are the other aspect, being in mechatronics students, you may have materials preparation, MEMS, smart devices manufacturing, and other things. These all things are came into the electronic origin or version. There, all the components are integrated in nature, tiny components, and very sensitive in nature, and it will give good amount of accuracy and sensitivity, and at the same time zero. Please remember. Therefore, a large capacitor C connected across the load will provide a continuous amount of voltage. Diode D prevents any current flow from the capacitor to the source. Step-up choppers are used for regenerative braking of DC motors. So this application may be later part. I think when we after the 5 units, we will discuss about some more application part. Okay. So at that time, I will have some more case studies and we'll have a discussion on solar panels. So how people are installing solar panel. How do you people can equip yourself and to that area, and how you people can equip yourself to go ahead with the charging station and other things. In houses, how do you maintain your inverters in a proper way with the help of with the maintenance of battery and other inverter? How do you allocate the load? These all things maybe in the later part when after the subject okay out of the box. Some case studies will have a open discussion so that I may also be able to get some more collective idea from you people because you are a third year, you people have good amount of knowledge on all those things because almost you are an engineer right now. Just one semester is left. Eighth semester you are not going to do any miracle here. You'll be hunting for job and other things. And that means you are in the sixth semester. That means only one semester only you are going to learn some more uh, 0.5 to 10 percentage. That means now 80 percentage you are an engineer. You people also have adequate amount of knowledge on the other things. So I can also extract some sort of knowledge from you people to nurture my minds and skills. And also at the same time, I can also share some of my expertise to you people, so that that collective expertise will bring us to a little more confident on the research perspective and the other findings and solution. Okay, so maybe in just overall view, I just to tell you there are various amount of braking system you will have, and here in the region, I think in the drive, people drives and actual writing you have learned about. Just, well, first quadrant, second, third, and fourth quadrant. What are all the kind of operations you may be learned? But still, this regenerative braking of DC motors, where exactly happened? If you see that traction, I think you all heard about the traction. In railways, we speak about all tractions, right? Locomotion. These areas where this regenerative brakings are applied is if you speak about all the locomotive engines or locomotion on railways, the trains and other things, there we people might be used on much of the application called the regenerating braking of the DC motors on the locomotion or the railways. Got my point? Maybe the later part will have a discussion. Earlier cases, locomotion highly hectic. I think you people never heard about that. With the help of a coal, that machine that railways were running, because you never got an opportunity to see all those things. Because during my school days, we got an opportunity. Once, if you travel for 3 hours with a white shirt, when you get down from the train, it appears like a black shirt. Just to tell you an example, the earlier one, with the help of a coal, the machine was the rail engine was running with the help of the coal energy. That energy only will be converted as steam. With the help of that steam, the machine was running. That the entire train system or railway system. If you travel just to three, for example, if I travel from my Chennai to for your place like Pune or Lucknow or Calcutta, then I'll sort of looks like a complete negro. My shirt and other things will be like that. Lot of the ash particle and other things, everything will be formed on our shirt and other things. That is what the system some 25 years back in the society. Maybe I think you can ask your parents. Some of the parents might have an experience. They might be worked in the railways and they may be worked running for long miles and miles together. But now people look into the other side, like electric train, lot of electric trains, electric bullet, electric gun motors in Japan and other China countries like China, Germany. They have other good system on the traction, and also now in India, we are going good with the diesel, right? Diesel engines. So after the diesel engines came into existence, okay, more amount of people are trying to travel via railways. And in Indian travel study, if you see that, more amount of people are utilizing trains, especially in northern India, the northern part of our country. Most of the people, even for the office and other things, they are preferring with the help of a resource that is diesel. People are speaking about that, right? So all these things, please remember this regenerative braking of DC motors now normally one of the good application on the chopper, on the aspect on the concept aspect on the locomotion. What are all the expressions for output voltage? Assume that the average inductor current. I told you when we discuss certain amount of theoretical way, we also should know little amount kind of expressions. Expressions for output voltage may be assume the average inductor current to be just a minute. average output inductor current to be high during on and off time of the chopper. When chopper is on, voltage across the inductor is what? In voltage across the inductor L equal to the amount of voltage. Therefore, energy stored in the inductor equal to V into I into T on. So T on is nothing but the on period of the chopper. Uh, I don't know how many of you remember, because you people are people never have an intention to discuss with me. All are silent observers and very sincere to be in time. Every day, that lot of positive aspect. All the fellows will be connected immediately. Even I don't wait for maximum of just 3 minutes to 4 minutes. Everyone will be connected. Do you remember this expression I told you? One important expression when we started the paper. I told you. When we discussed about L and C, two important expressions we should remember. If you remember that expression, these all concepts are very simple and nothing to recollect. And when we speak about the statics, electrostatics, the amount of stored energy might be taking it as 1 by 2 CV square. When it speaks about 1 by 2 CV square, I think you might be learned, right? Half CV square. So C is the capacitance and V is the voltage. I hope you remember. I think maybe in the physics you might be learned the same equation the other way, like law of conservation of energy in the way of 1 by 2 CV square, or energy can be neither to create or not destroy, energy can be transferred from one place to another. All energy phenomena, whenever you speak it in physics fundamental, because this is an origin of semiconductor physics, there you might be learned definitely. Okay. Maybe we do not know what exactly the meaning of the equation and where people are exactly using about that. Same thing, when you speak about in terms of a magnitude aspects, please remember the energy stored, the inductance equal to 1 by 2 Li square. Please remember in your mind, 1 by 2 what? 1 by 2 CV square is transformed to what? 1 by 2 Li square. C is transformed to what? Inductance. Voltage is transformed to current. Always that thing, please remember. Okay, being mechatronics, you are learning multidisciplinary areas. So at least in electrical, these two things at least please remember. You need not remember all those things are accountable. At least you remember a limited things limited things which is accountable here. For example, voltage across the capacitance we consider, current through an inductor we consider. L and C are cumulative. We call it as the storage energy. Therefore, the energy stored in the inductance or V equal to I into T on, or otherwise we can write it as 1 by 2 L I square. L is the inductance and I is the current. Please remember. When chopper is in off condition, energy is supplied by inductor to load. Thereby what will happen? Voltage across the load equal to the maximum voltage, output voltage minus the input voltage. Therefore, energy supplied by the inductor equal to the cumulative amount of voltage, the previous voltage into the current amount of time duration, or into T of time period. T of is nothing but the off period of the chopper. If you consider about the losses, or if you're neglecting, or if you just ignore the losses, energy stored in the inductor equal to energy supplied by the inductor. So please remember one of the important inference, because there I told you, right, there are practical losses we may have. So in cumulative together, we may speak about that. Energy stored in the inductor is equal to energy supplied by the inductor capital. Got my point? So energy stored is equal to the amount of energy which is retrieved or supplied by the inductor, or the amount of energy which is drawn through the inductor during the time period, during the T of period. Therefore, I write the equation V into I into T on equal to V into I is what? The amount of power. V equal to the amount of power which is derived. V into I into T on equal to the voltage difference. The voltage difference is what? The output voltage minus the input voltage into I into T of period. Therefore, from this equation, from the previous equation, the center part you have output equation. If you arrange the equation, you will get V output equal to V into T on plus T of divided by T of. T on plus T of divided by T of might be written it as what? T divided by T minus T on, or the switching time of T. So these are all the various equations we can write for a step-up chopper with the help of one aspect on the inductor and another aspect on the capacitor in terms of the power which is drawn, or in terms of the voltage which is drawn. Please remember. Therefore, output voltage equal to input voltage into the duty cycle ratio value or the on time and off time. On time means the chopper is in on condition, off time means the discharging time. But my point. So you all know that when it is in on condition, when it is in off. During the charging time, we may treat it as an on, and during the discharging time, we may consider it as an off condition. But my point. So T is the chopping period or frequency of switching. So therefore, capital T equal to on time plus off time. You all aware about that. Therefore, same equation only. Please remember, just in the various form they are writing. Okay, you need not worry about that because I told you about that output voltage in terms of the input voltage with the duty cycle we have written with the on time and off time. Now, with the help of a duty cycle, same equations are slightly adjusted. As, divided by the sum term, like V not equal to V into 1 divided by 1 minus T on by T. T on by T will speak about duty cycle, small t. Already we discussed on the first case, right? Step down chopper, same expressions. They're trying to incorporate it here and they wanted to bring it to the uniqueness of the expression. So therefore, V not equal to V into 1 by 1 minus T. You may ask a question, will this equation is the right one or that one is the right one? All the equations are the right one. Here this equation, the final expression, please remember, V not equal to V into 1 divided by 1 minus D. That means D is the duty cycle. What is the duty cycle ratio expansion? T on by T. What is the T on the T expansion? T on plus T off. Like that, if you put every expression or to the consecutive previous step, you will come back to the original. That is what the meaning. So please remember, try to understand the meaning. It's not a tough derivation or something else. It is very much difficult to know. So please remember in your mind. So therefore, the step buck boost operation or boost operation, output voltage V not equal to V into 1 by 1 minus D. D is the duty cycle or T on divided by T. T is nothing but the on time plus off time. But my point, small d indicates what? Duty cycle. Got it? Even the previous equation, they have written V into 1 by 1 minus D. V into T by T minus T on. T is nothing but what? The total chopping period. And T on is the on time period. Right? Same thing only. That is in terms of a open circuit voltage or output voltage. Same thing in terms of a duty cycle ratio. They have written V not equal to V into 1 divided by 1 minus D. But my point. So same set of output equation only, writing it in various terms of on time and off time period, in terms of on and off, in terms of the duty cycle. But all together, on and off together speaks about time period and duty cycle ratio. What is duty cycle? On time divided by on plus off. On plus off together call it as what? Total time period. But my point, finally, for variation of duty cycle, D in the range may be 0 less than D less than 1. The output voltage will vary in the range. V is less than output voltage less than infinity. That means if you keep on varying the duty cycle ratio, the range of 0 less than T less than 1, the output voltage will vary in the range up to infinity. So I think with this I'll try to wind up today's class because still more things are there. If I go, it will take more time. I think now the time is to 2 almost. So Veda, one fellow's mic may be on. Please mute yourself. His name is Venda or something. The kind of noise is rising. So please, Guru Venda. If anybody is there, please pass a message to him.
Sir, he's muted his mic.
Yeah. Okay, I think with this performance criteria, we will do it on, I think, the next class. Because, many things we have discussed, and now the time is almost to 3. Okay, now I'll take the attendance. Okay. So up to this, I'll stop for today's class. Okay, the next class will speak about the performance parameters. Okay. So it's not at over. Okay. So once the entire PPT gets over, I will just upload. Maybe in the next week, I will try to complete and I'll upload it.
Okay, sir.
This all things comes under unit 2 only. Okay. So the discussion in the previous class, And base class, whatever we are doing here, everything comes under the unit 2 only, but still some of the slides are there. Maybe in the next week we'll have a discussion, then finally I will upload it. Okay. So if you keep on splitting and uploading, then there will not be much continuity. You won't get any continuity. Because we are categorizing very clearly chopper and rectifier, right? The second chapter is just divided into two categories. One may be chopper aspect, and another one may be on the rectifier aspect. Okay, guys, thank you. I'll take attendance. Please be online. I think almost everyone present. Guys, please respond your attendance. Number 26, Mohit Jain.
Present, sir.
Number 27, Saravanan.
Present, sir.
28, Nikesh.
Present, sir.
29, Dhananjay Chauhan.
Present, sir.
30, Srishit Arya.
Present, sir.
31, Sanjay Patil.
Present, sir.
32, Sri Darshan.
Present, sir.
33, Vishnu Roop.
Present, sir.
34, Tarun.
34, present, sir.
35, Jaideep Singh Bindra.
Present, sir.
36, Anshul Mehta.
Present, sir.
37, Mugilan.
37, present, sir.
38, Mohan
38
Sundar.
present, sir.
39, Nitish Reddy.
39, present, sir.
40, Manishalvan.
40 present, sir.
41, Mohammad Zahid. 41, Mohammad Zahid. Muhammad is there or in between he left or anything? 42, Matheswaran.
Present, sir.
43, Sudarshan Banerjee.
Present, sir.
44, Jeshwant.
Present, sir.
45, Suraj Menon.
Present, sir.
46, Ritesh Babu Alam.
Present, sir.
47, Mark Henry D'Souza.
Present, sir.
48, Siruguru.
Present, sir.
49, Sylvester Francis.
Present, sir.
50, Bharatwaj
Present,
Srinivas.
sir.
51, Jubin Kurian Baiju.
Present, sir.
52, Hari Krishnan.
Present, sir.
53, Harshita.
Present, sir.
54,
Present, sir.
Banoday.
Present, sir.
What is the pronunciation of your name?
Banoday, sir.
Before the name, so your surname.
Garikipati. Garikipati, sir.
Okay, fine. 55, Mohammad Naeem. 57, Subin Babu.
Present, sir.
58, Param Bisha. Number 5,
Present, sir.
59, Abhi Shah. 60, Jai Shankar.
60 present, sir.
61, Darshan Bharat.
61, present, sir.
62, Venish Krishna.
62 present, sir.
63, Pawan Ganesh.
Sir, message in chat.
Okay, 64, Joel Zakaria.
Present, sir.
65, Charitesh Vimula.
Present, sir.
66, Harigaran.
Present, sir.
67, Jiva.
Present, sir.
68, Abhijit Vijay Kumar.
Present, sir.
69, Samuel Pillai.
Present, sir.
70, Hemanand.
Present, sir.
Sorry, Kemnath.
Present, sir.
71, Shikil Pranit.
Yes, sir.
72, Raghavendra.
Yes, sir.
73, Jakish. 73, Jakish. Any idea, Jakish? 74, Aturi Chandan Sai. Number 74. 74, Aturi Chandan Sai. Number 75, Aishman Bhatia.
Present, sir.
76, Kola Shanmukh Sai.
Present, sir.
77, Alok Ranjan Panda.
Present, sir.
Okay, I read after this name. If anybody is there, please respond me. And one more important announcement I just wanted to give. Number 41, Mohammad Zahid. Number 41, Mohammad Zahid. Number 73, Jakish. 74, Katuri Chandan Shai. And just a minute, regarding your CT1, I think next week you will have CT1. I hope you got the announcements and other things. Maybe by Wednesday, I think day order 5 next week. Today's day order is due to the